excuse me drinking, but I fancied something. Cold and fizzy. You do sometimes, don't you? Anyway, welcome back to part 2 of the AVO valve tester Mark 1. Those of you who've seen my last video knew that I was getting a bit lost on it, but then I had a rethink and I decided that the obvious way to do it, because there's no active components in it, is just to do some basic voltage checks and continuity checks. And I've been doing these, the main side of things going in looked okay. I had outputs eventually when I measured it correctly from the transformer, because it's not all referenced to the same common on this side of things. And then I looked at the circuit diagram and I thought, well, if this thing is going to work, the fault could be in two places. It could be to do with the meter or the switching of the voltages within this unit, or it could be to do with the volve base unit here. But I've done some continuity checks on that and they all seem right. So I thought the next obvious thing would be to check the voltages from the connector to the volve base piece of the equipment, because on there you have your anodes, you have your you have your cathodes, you have your heater connections, you have your screen grids, everything is on there basically. So if I check that, now I've cleaned all the switches, and if they're correct, then it should be possible to test a valve. Now I have cleaned all these switches quite thoroughly, not with anything abrasive, but just with the standard switch cleaner, fast drying contact cleaner. And then I took the opportunity then to actually move all the switches round and do all that stuff, just to make sure that everything was clean. And these switches, moved all those around and just made sure everything was cleaned. I did think there was a little bit of a problem with the on and off switch. It didn't always seem to click properly, but now it seems to be working fine, but I'll keep an eye on that. So the next stage was to turn the machine on, turn it over. Now it's very easy to kill yourself on this because you've got 240 volts clicking around all over the place, so be careful with it. And then I thought, well, the obvious thing to do now is to check the outputs that are going on this switch here, or on this socket here, which are going onto this plug. And if those are correct, then things should be okay. And that's what I did. I checked for heater volts. I moved the heater switch around. I won't actually do it again now because it's a bit complicated to get it all connected up. But I connected, once I'd found out what pins were what, connected heater volts and checked HT, and it all seemed to be there. And it seemed to be variable when I changed the switches on the top. So that was basically an easy and logical step to go to making sure everything was working. I also did a smell test to make sure everything was there was no smell of transformers burning up, and there wasn't. It was all absolutely fine. The only thing I haven't tested is this capacitor here, and I might actually replace that in any case. It's a paper capacitor, and what microfarad is it? Does it say? Yes, it does. 0.05 microfarads, 400 volt working. So I think I'm going to replace that, and then I'll get back to you and show you the results of this by testing a valve. And I've chosen a couple of valves to test. I've got the book to do it, and you know, the valve reference book, which is this one, so I can look up all my valves in here, and get the switch numbers for the switching unit. Having done that, I should be able to test the valve once I've read the instructions again, because you forget. So let me change that capacitor and then I will be right back with you. Okay, so the way I'm going to do this is first of all desolder it from this end and then check it. But I've got a feeling I'm going to replace it anyway. Let me come back a bit so you can actually see the whole thing here. So I'm going to desolder it from this end. Put a little bit of soldering on. I don't think there's any need to use soldering braid on it. I think probably it will come. But these things are made so well, and the solder joints are very, very good. It's not and they're of course wrapped. Oh, although that one wasn't. So it's that one there. I'm going to actually take a photo of it, because sometimes if you get disturbed and you go back, you don't actually know where you've taken it from. So I'm just going to take a photo of that, if I can get it back on there. So that's where it goes. Photo done. Right. And then I'm going to take it off from this end. And I'll take a photo of that as well. You can't be too careful with these things. Sometimes I've known the phone to go or something like that, and then you go away from it, and before you know it, you come back and you think, oh, did it come from there? Right, that one's out. That was out quite easily. So what I'm going to do now is test this. So let's go in and do a test on it. Okay, so I've got the removed capacitor on test. It should be measuring 50 nanofarads or 0.05 microfarads. It's actually measuring 189 nanofarads. Yes, it's not good. So let's just check the 0.47 that I'm going to fit now. Let's do this without getting a shock. So I'm fitting, checking this one, which is a new 0.47 microfarads, and it's actually measuring 47.4 nanofarads, which is 0.47, which is excellent. So that's great. Okay, so new capacitors fitted in place. I'm not absolutely sure what the function of it is, but it's something to do with the I'll have to look at the circuit a bit later to find out exactly what that capacitor does. But it's certainly going to work better than the replacement one did that I've taken out. I think that's all I can see to do here now. It's all looking very clean, it's all looking very nice. So I'm going to take it back onto the other bench, power it up and try and test a valve on it. So let's go through the basic stages of testing a valve. The valve, which I've now inserted, is an ECH81, and it was designed in 1954, and it's a triode heptode, a frequency changer valve. I've set all the digits up according to the valve manual, so it's correct, and I've actually at this stage turned on the meter. You can see it's turned on here, and you will notice a slight deflection showing the initial anode current on the meter. The book does say that you have to set this switch down to set, right down to the bottom of the MAV here, in case it damages the meter. Once that's done, you need to zero that off with the set zero control, which I've done here. And after having done that, you can press this switch to show that there is to the MAV to show there is conductivity there. The next step is to set this one to the MAV listing that you have in the valve manual. So I'm going to do, oops, it's going negative there. So I'm going to move that one up slightly, and oh, there we go. What's going on here? I'll set it to 0 again before I move that. That's what I need to do. So I'm going to set that back to 0 and then move this one to the correct MAV listed for the valve, which is 4. Set that to 0 again and then move this one to MAV. Wow. And that should indicate a good valve, which it does, which is excellent. I am not going into the intricacies of actually measuring the and analysing what the MAV and the emissions of the valve are, but just to prove on this that it is good there. Now the other way of doing it, according to the book, according to the manual, another way of testing it is to move the take the MAV control off set here and put it to the MAV position. It's not very clear, but that's it there, and then make that back that off to 0 again, and then move it up, and that will actually give the indicate the milliamp volts of the the valves actually producing. The mutual conductance in MAV, and then it says compare that with the figure given in the valve data manual for that particular valve, and that one there is it's reading about 5, which is absolutely great. So that's 2 methods of measuring the valve, and obviously it's working quite fine. Now we have it, because we have anode 2 on here, we can check that as well. So if we've got to be careful there. The problem with this is that the meter is, it tends to go very negative at times. So if I go on to anode 2 and set the voltage up for anode 2, which is, where are we here? That goes up to 90 volts, I think, and then move that over again, we can then check the second anode on the valve. So yes, it all appears to be working absolutely fine. And without going into the intricacies of measuring this and doing accurate measurements, I just want to use this video as a demonstration that this valve tester is working and will check valves, and I'm really, really pleased with that. Now that was a 1954 valve. I think maybe the proof of the pudding is going back to a very early valve and see if we can set that up and test that. Okay, let's give this one a try. I've dug this out, this N16. Now the N16 is a pentode with an octal base, and produced around 1935. So I've fitted it in. So let's power up and see what happens here. I've already set up the wheel with all the correct configuration. So let's have a look and see what this one does. So let's see what we're getting on this valve. So let's turn it on, and right away we can see that some anode current flowing. So let's do the basic checks on this one. Let's first of all zero it with the set 0, and then we'll turn this to MAV here, and then 0 it again, excuse my fingers, and then move this over to MAV, and we've got a reading on it, and it says 3.2. The book actually says MAV for the N16 should be 2.1. So so we're working, the valve is working okay. Let's do the good bad check on it And to do that, we let that go. We actually set this up to the MAV of the valve itself, which in this case is around about there. Zero it again, and then push this down to MAV, and there we go, we've got a good valve. So for a valve of that age, that's not bad, is it? It just goes to show that vacuum tubes don't fail that often, and they're pretty reliable things if they're looked after. Anyway, that's that one done. I think that's enough of the actual valve testing. I've apologised for my lack of finesse and detail and the actual readings, but I'm still learning this, and as I get because it's been many years since I've tested valves, so I need to sit down and read all the manual properly and make sure I'm doing the right thing. But I'm fairly happy that this instrument is working absolutely fine. Some of you who are eagle-eyed may have noticed that the neon in the centre, which is used for insulation checks and other and should be glowing, isn't working. There is voltage on it, but that's just a minor thing. However, the volt tester is working, so let me get back to my desk and we'll end this video. Hello and welcome back to the desk. I've quite enjoyed finding out all this works. One of the things I'd like to say about the valve tester and looking at the patents for it and the design of the thing, it's just totally remarkable that you can test valves using AC only. There's no active components in that. There's no DC power supplies, which would have to be very accurate, and a lot of them, to get anode voltage, grid voltages and screen voltages. But it's all done using power taps on AC transformers, with one exception, and that there is one diode in the thing which actually is used to do the grid bias voltage on it. But the way it's worked out is incredibly complicated. I haven't understood it completely yet. I'm going to have a read of this book, but I'll show you a page of the mathematical arguments that allow this to actually test valves using just an AC supply, which minimises the size of the tester because there's no DC supplies in it, and the whole thing works absolutely fine. Right, I've gone on a lot on this video, but I'm really pleased to have done this one. Although it's the last job I've actually got to do, but now I've got a valve, an AVO, a lovely AVO precision meter, which I showed in another video. I've got this valve tester which is working. The only other thing I may dig out, I think somewhere, I've got an AVO 8 which has seen better days, and I may look at that. But for this video, I think we're coming to the end. Oh, there's one other thing. One of the valves I've turned out is this one. I'm not really sure. I can't make out the numbers on it. It's a 4-pin valve. I'll give you a close-up in a second. But as far as I can see, it's a BRC label on it. Bit of update voiceover here. After looking closely, I can see it's an Edison valve, BRC in the center, and it's a 730. So if anyone out there knows anything about this particular valve, then please let me know. I've got some other ones like this as well, or similar to it. Thank you for watching the video. It's been enjoyable making it, and a big learning experience for me as well, and I hope that it has been for you. Thank you for watching, and I don't know what my next video is going to be, but I'll be back with you fairly soon. So thank you, and as always, take care. Oh, one more thing. It was my birthday yesterday, so you could say this was my birthday video. Take care.